So in this problem, there's this motorboat that has a speed of 9 kilometers per hour when it's sitting in water that is still. Now this boat's going to travel 12 kilometers downstream, and it's going to come back upstream in a total of 3 hours. And we need to find the speed of the stream that is pushing this boat along. So let's start out with our boat. What do we know about our boat? Well, we know that its speed in still water is 9 kilometers per hour. And when boats go downstream, they're going to speed up because of the force the current is applying to the boat. Now, we don't know the speed of the stream, so let's just say that our speed of the boat going downstream is our base 9 kilometers per hour plus some unknown speed of the stream, and we'll call that x. Now, when our boat turns around and goes back upstream, it's going to be fighting against the force of the stream. So this means that the speed will be less than what it is when it's in still water. So let's say that our speed of the boat going upstream is our base 9 kilometers per hour, and we're going to subtract that unknown speed of the stream, again, calling it x. So that's everything that we know about our boat. Now we're also told another piece of key information, and that is that the boat goes a distance of 12 kilometers downstream and comes back, meaning we have 12 kilometers downstream and 12 kilometers upstream. So let's just remember that our trip has two parts to it. Now, one thing you might know is that there's a relationship between distance, speed, and time. Namely, that speed is equal to distance over time. And we can manipulate this relationship by multiplying time up to the other side and dividing by speed in order to isolate our time variable. This leaves us with a new equation, time is equal to distance over speed. Now let's go back to the information that we have from this problem and let's write out some expressions for time. Remember, we're going to have two times, one for downstream and one for upstream. So using this definition of time as distance over speed, replacing our distance of 12 kilometers in our numerator and our speed of 9 plus x in our denominator will provide us with 12 over 9 plus x as our downstream time. And for our upstream time, we're going to have that same distance of 12 kilometers, but we're going to divide by our speed of 9 minus x. So we have two expressions for time, one for downstream, one for upstream. All right, so what are we going to do with these expressions? Well, let's talk about the total time of our trip. We know this whole round trip down and back upstream takes 3 hours. So let's set up a simple equation so we can start solving this problem. We know that the time it takes for the boat to go downstream plus the time for the boat to go upstream is 3 hours. We're told in the problem that this entire journey takes 3 hours. So if we write out an equation that says time downstream plus time upstream is equal to 3 hours, we can fill in our two expressions from earlier here to create an algebraic equation. So making that substitution will result in 12 over 9 plus x plus 12 over 9 minus x equals 3. And here's where the fun begins. Our goal here is to solve for x because that's going to tell us the speed of our stream. Now notice that our unknown variable x is in the denominator. Now we don't like this because it makes it hard to solve for it. So what we're going to do is multiply both sides of this equation by each of our denominators. Now this step is going to allow us to eliminate the denominators, leaving us with a much simpler algebraic expression to solve. So when we multiply each side of the equation by our denominators, we end up with this big mess, but all we really have to do here is just use the distributive property to clean things up a little bit. So on the left side, I'm going to multiply 12 into each set of brackets, and on the right side, I'm going to expand and simplify here using the FOIL process, which tells me to multiply the first terms, the outside terms, the inside terms, and the last terms. So performing those steps is going to allow us to eliminate our brackets, and all that's left is just to clean up this mess by collecting like terms. Remember that like terms have the same variable and same power. So we can collect anything that has an x together and separately collect anything without an x. And we only have this one lonely x squared that doesn't have any like terms. So negative 12x and 12x are going to cancel. We're going to add our 108s together to get 216. And we're going to subtract that 243 over to the left-hand side. So after all this work, we have a very simple equation that's going to allow us to solve for that speed of our stream. And we're at a point where we want to square root both sides so that we can find the value of x, not x squared. Now, normally when we square root a number, we consider both positive and negative answers. And we're not going to consider our negative answer here because a speed of negative 3 would indicate that the stream is flowing at negative 3 kilometers an hour, which actually makes sense since the stream's flow can have a direction. It could flow up or down, but we're just going to stick with our positive answer since it makes sense in the context of the problem for the stream to only be flowing in one direction. So taking the square root of 9 will result in 3, and therefore we can say that the speed of the stream is going to be 3 kilometers per hour.